Here it is. And welcome to the final session of Statistics Can Be Fun. It's hard to say after a holiday, isn't it? Can they be fun? Yes, they can. So today we're going to take everything that we've learned in the previous sessions. We're going to put it all together in one large analysis from the very beginning of the analysis to the very end. And we're going to use a live data set that I used for my honours thesis. But we're going to look at variables in a different way to what I did in my thesis. So I'm hoping that as we go along, little issues will come up. So the common issues that come up whenever you are doing a data analysis, and we'll have to make decisions on that live data set. Because what I want everybody to understand and realize is that when they have data and they go to apply the steps that I have taught everybody, that along the way, decisions need to be made about which way to go. It's kind of like one of those books that we used to read in primary school where you read it and then each page has like, if you want this to happen, go to this page. If you want this to happen, go to that page. That's what data analysis is like. There's always a crossroads where you have to make a decision about certain things. So we're going to go through that today, and hopefully we have some issues and decisions that occur while we're going through our data set. So I have actually cleaned the data, so we won't have to go through that again, but we will be transforming some variables from continuous variables into dichotomous variables, which means basically turning them into two categories, so binary. And I'll tell you the reason why we do that in a second. So I will bring up my data set. Okay. Can everybody see the SPSS variable? Oh, it's the data view. Can everyone see that?
Yes.
Great. I'll switch over to the variable view. So the first thing that we need to do once we've collected our data is to refine and understand our research questions, what our dependent variable and our independent variable are. They are very important. When I started my honours analysis, I had my independent and my dependent variable in my brain around the wrong way. So when I did my first set of analysis, I did my data analysis around the wrong way, and I was looking at the variables in the wrong way. My supervisors pulled me up and we ended up fixing it up. So it's very important to write down your research question before you begin your data analysis. Write down what your DVs are, what your IVs are, and then what kind of your covariates might be as well. So today, the data set that we're looking at, which I used in my honours year, we surveyed 760 women who were in the postpartum period. So they had children between the ages of 0 and 4, or 0 and 5, I think it was. And we were asking them things about their body image. We were asking them about their psychological well-being. We asked them about self-esteem. We asked them about their eating patterns. So we asked them two ways. We asked them about whether they restricted food and dieted, or whether they ate intuitively. Now, intuitive eating basically means that you eat when you're hungry, you know when to stop when you're full, you listen to your body's internal cues about how certain foods make you feel, and you eat in the way that your body tells you to. And it's very difficult to intuitive eat when you're an adult because we've been trained not to. From our parents way back when, we were told to eat everything on our plate, or we couldn't have dessert. And we can't blame our parents for that, because this is like, they were trying to get us to eat healthily. You will notice if you watch children that they eat intuitively. So they will graze throughout the day. They'll eat when they're hungry. They don't really stick to these breakfast, lunch and dinner type meals that society eats. And they'll eat when they want, what they want, if you let them do it. And that's kind of what intuitive eating is. So that's important to know, because it's one of our most important variables. We're also going to have a look today at the other side of the spectrum. We're going to look at disordered eating. So that's a little bit different to dieting and food restriction, because you can diet and have food restriction without being disordered. But we also have a variable here that measures disordered eating, and we're going to have a look at that. So our two research questions that we are looking at today, the first one is, does intuitive eating reduce the symptoms of depression in women in the postpartum period? So that's what we're trying to find out. We're going to find out, number one, whether intuitive eating decreases the symptoms of depression and whether dieting and food restriction increase the symptoms of depression. The second research question that I think is really important, something that I didn't look at in my honours year and I wish I had, so we're going to do it today, is intuitive eating and disordered eating just two ends of the same spectrum? Yeah? So eating intuitively and eating what you want, is it really just the opposite of disordered eating? Because that's something that's been written into the literature. So a lot of people in the literature say that eating disordered or disordered eating and intuitive eating are actually the same concept, but at different ends of the spectrum.
Excuse me, Megan.
Yep.
What is disordered eating?
Oh, good question. Excellent. So making sure that our variables are very nicely and clearly defined. So disordered eating is when you diet or restrict food and it controls your life, so it becomes disordered. So we're talking anorexia, bulimia, binge eating disorder, those types of things.
Okay.
So anything where dieting and food restriction becomes disordered is when it starts to affect your life. It starts to affect you socially, it starts to affect you, your employment, it can affect your life.
Okay.
So same as other mental health issues. Nothing is disordered until it starts to affect the way that you function in life.
Okay, thank you.
Excellent. Cool. So here we've got our variable view, and in our variable view we have our demographics like age, marital status, income, education, employment, how many children the women had, what their BMI was, which we didn't ask them that, we asked them their height and their weight. And we calculated BMI, but I showed you how to do that in the last couple of sessions, so we won't go back through that. We also asked them about their height and weight before their first child and their height and weight after their last child, or before their last child. We asked about the age of the children, and then we asked them 28 questions about intuitive eating. And those questions ranged from, I count calories. One of my main reasons for exercising is to lose weight. I'm hopeful one day that I find a new diet that helps me to lose weight. The health and strength of my body is more important to me than how much I weigh. So there's a couple of reverse coded questions in there as well. Now, a higher score on the intuitive eating scale means that there are higher rates of intuitive eating. Then we have the EAT 26, the eating attitudes test. It tells us whether or not people have disordered eating. So anything greater than 20 on the eating attitudes test indicates some disordered eating. And then we've got our postnatal depression scale. Higher scores on the postnatal depression scale indicates higher depression levels. But unlike the CESD, which is the one that we looked at last time, so the Centre of Epidemiological Studies on Depression, remember I said it was very, very important to ensure that we were reporting our variables properly, because the CESD is a scale that is used mainly in research. It's not really used in clinical diagnosis of patients. And so it's actually measuring depressive symptoms or the occurrence of depressive symptoms or the kind of spectrum on which someone feels depressed. Whereas the postnatal depression scale that we are using today is a diagnostic tool which is used clinically to diagnose people with depression. So they're two very different things. So when you're reporting this scale, you would report depression rather than the symptoms of depression. So it's also very important before you start doing your analysis that you understand what your pre-validated scales measure. So going back, reading the scientific literature about what each of the scales measures, what they range between, what their cutoff scores are, and really, really understanding that. And I always kind of write it into the label so that when I'm looking at the data, then I kind of can remind myself, oh, okay, that's what this means when I'm looking at the means and the patterns in the data. Cool. So that's all we've got today. All the rest of these variables are just the questions that were asked in each of the scales. Excellent. So, can you tell me what our research questions are today?
It's too early in the morning, Megan.
Too early to remember. That's okay. The first research question.
Wasn't it does intuitive eating decrease postpartum symptoms? That was one.
Of depression?
Yes.
Yep. Does intuitive eating reduce the symptoms of postpartum depression? Very good. And our second question, which is the one that I didn't look at in my honours here and I really wish I had, was, is intuitive eating and disordered eating on just two ends of the same spectrum?
Yes.
Or are they two completely unrelated variables? Now, this is really important for the literature because there's kind of an argument in the literature about it at the moment that hasn't really been teased out. Some people are saying that intuitive eating and disordered eating are the same thing, they're just two different ends. One's the disordered end and one's the non-disordered end, whereas other people are saying that intuitive eating is a completely different concept to disordered eating, and it's not just the positive side of it. So that's something we're going to find out today. And maybe we can write a paper together and clear up the confusion in the literature. All right, so for research question number one, who can tell me what the independent variable would be? Now, remembering the independent variable is the variable that we are manipulating.
Is it
intuitive eaters?
Intuit, yeah.
Yes. What's our dependent variable? The variable we're looking for the outcome in.
The postpartum, symptoms of depression.
Excellent. Perfect. Good job. Now, question number two, both of our variables are the independent variables, so there's no dependent variable in that one, but we're going to test that anyway, and I'll show you how. All right, so the next thing that we do, once we've got all the variables all nice and clear in our mind, the next thing that we do is we want to look at our descriptive statistics. So we want to take our 700 or so women, and we want to know what they kind of look like as a population compared to other postpartum women in the world. Now, one thing that has happened in this data set, and is probably a good thing not to do, so I'm going to tell you something, a mistake I made when I did this data set. So I had 700 and something women complete my data set in 3 weeks. It was amazing, very quick, very popular. But what happened was, when I was constructing my survey, I made informed consent. When I put the informed consent into the survey, I made it that the informed consent was a condition of finishing the survey. So the participants had to click on the submit button for the survey at the very end and finish the last question for their informed consent to be approved. Now, I wish I hadn't have done that, because that then erased nearly 350 participants. Some that I didn't do the last kind of couple of questions, some that didn't finish it. And so I would highly recommend to anyone who's constructing surveys not to do that. Make informed consent right at the beginning, first page. This is what you will expect from this survey. This is what you should expect from us. This is what we expect from you. Do you agree? Here is informed consent. Push this button. Then get them to do the survey. That way, you can use participants who don't completely finish. So if they've done 70 to 80% of your survey, then that's okay. Another thing that's really important is don't put the dependent variable questions last for the same reason. Because if people get fatigued and don't complete the last kind of couple of questions and it's your DV, then you can't use it. So I suggest, and I've done it completely the opposite way around, but I suggest putting demographics last because they're not as important. Put your important stuff first, put your demographics last. Yes, Dennis?
I was just thinking, this is all very interesting for me because I'm not a great statistician, but I keep seeing the value of statistics. What you're saying is interesting to me because I was told to put my demographics first because it sort of waltzes people into the survey. It's an easy way to get in, but I do get your point because a lot of people dropped out in my survey.
Yeah, and then if you put your dependent variable last or the questions of an important variable last, then those who get fatigued and kind of drop out, you can't use their data. However, if you want, you can put your demographics first to ease your participants into your survey, then put your independent variable, so your most important manipulating variable first, then your dependent variable second, and then anything co-varying kind of last. Because in this survey, I had intuitive eating and I had depression. And then I also asked questions about self-esteem. I asked questions about body image satisfaction. I asked questions about body self-relations. I asked questions about kind of 4 or 5 other co-varying kind of scales that I wanted to know about, but they weren't really that important to my primary research question. So put all your important stuff first and then your co-varying interesting stuff last, just in case people do drop out. Because that was a mistake I made in a recent survey that we were told by ethics, because it was about depression, and the one that we looked at before about vegans, vegetarians and depression. And we were told by ethics that they didn't want us to end on the depression questions because it would leave the participants leaving the survey feeling down. So we put our food questions last, but then we couldn't use the data of anyone who dropped out early because they hadn't completed the IV. So it's just things to think about. And you learn as you go along, definitely, from mistakes. That's how I learn everything, the hard way. All right. So they're just a couple of tips, especially if you're thinking of doing survey construction. So our next step is our descriptive statistics. So we're looking at what our data looks like. So let's do that. So just like before, analyze descriptive statistics. We're going to do our categorical variables first. So our categorical demographics first. Frequencies. And we're going to look at age is continuous because it's got the little ruler. We're going to look at all of the data that is categorical. So all the ones with the red, blue and green circles. So we're going to look at what marital status looks like, household income, education level, employment status, how many children they've got. I think that might be it. Yep. Everything else is kind of continuous. I've got all my scale questions continuous. That's not right, but that's okay. We're not going to use them. All right. We don't need any statistics because this is categorical data. We're just going to look at a bar chart. Yep, that's right. Of percentages, because percentages are so much easier to interpret than frequencies. So continue. Okay. And then we will get our, hopefully, our data. Now, before we look at the frequency tables, I like to look, because it's kind of confusing to read the statistics table. So I like to just go straight to the bar charts, because looking at a figure is so much easier than interpreting that table, right? And we can see the figures on the bar chart. So what's this bar chart on marital status telling us about our women, our postpartum women?
Most were married.
Mostly married. With this data, when I'm putting this into the participant characteristics table, I would transform this data into partnered and unpartnered. Because you can see there married and de facto would be in the same column, and then single, separated, divorced, and widowed would be in the same column. And then I would report something like 85% of the women in the data set were partnered and about 15% were unpartnered.
Okay.
Yep, easy. So manipulating your data around a little bit so it's easy to report. What about income? What do you reckon about that? What does that say about our women?
Middle.
Yep.
Middle income group.
Yeah, they are. What's $2,000 a year? $2,000 when you go per annum? 204?
100, just over 100.
Yeah, so anywhere between $50,000 and 104. That's household income though. And that's probably on the lower side because the women are in the postpartum period. So a lot of them probably aren't in the workforce. So they're probably relying on one income.
Yep.
So that's kind of fitting with what we would expect. Also with this one, when I report this in the participant characteristics table, I would report less than $2,000 and greater than $2,000. I don't know why I chose these because these don't actually fit within other literature, how they report income. And that would just be because I was a complete research virgin at the time. I had no idea about anything. So I didn't use a pre-validated scale. But anyway, I think I was working on socioeconomic status because I was trying to see any women who were lower than, were in the lower SES. I think that's why I did it. Anyway, it's funny when you look back on your old statistics. Okay, education level. So what's this telling us about our women?
Probably more highly educated than average.
Now, this is a common problem that we find in most research, that most, especially psychological research, most people who are interested in it are more highly educated. So we're very rarely getting the opinions or the answers from people who are in that lower educated bracket. That's one of the things that I found in my focus groups with my PhD as well. Pretty much every single person that we talked to in my focus groups on food and mood were either at uni or had a university degree. So we weren't really getting the experiences of people who kind of were on that Western dietary pattern. Everybody was kind of health conscious, which comes with being more highly educated. So that kind of is a major limitation of my PhD research. But anyway,
the lesser educated group would probably have lower levels of health in general, wouldn't they?
Yeah. So we weren't, pretty much every single person that we talked to in my focus groups were either on some form of diet or like gluten-free or some form of health related dietary pattern, or were like vegetarian or vegan, and it was really interesting because everybody I talked to was health conscious. We did not talk to really any participants who were on that really white bread Western dietary pattern. So we're missing that completely.
Where did you find these people, Megan? Where did you look for them?
How do you think I recruited Dennis?
Just up the hall.
I convenience sampled staff and students from SCU.
Okay.
And accredited practicing dietitians from Griffith. So it was like my own fault. But so it can be, I would actually like to redo it and like specifically recruit that
normal people.
Yeah, people who eat the Western dietary pattern and disinclude people who are on like special, who are eating healthy already. Anyway, so highest education level. I would, in this participant characteristics table, I would split this into high school, school educated, trade and university. That's what I would split these into. And I would say something like 50% of the participants were had a university degree, about 34% had a trade or a certificate, and 20% had a school, had finished school, something like that. All right, employment. This one's interesting because this is very different to the normal population. What are we looking at there?
Well, they're at home with their little kids.
Yeah. So it's not the same sort of data that we would find in a normal population. So we've got a lot of homemakers and students. We've also got a lot of part-time and casuals with very few full-time or self-employed. And that just comes along with the fact that they've got little kids. Very interesting. I would split this one into, I would put homemakers by themselves, students by themselves, and then I would put part-time and casual together and full-time and self-employed together and report them like that in the characteristics table. Number of children, what have we got? Most have 2.
Pretty normal.
Or less than 2. It is now. That would have been different back in the 80s. It was, I think 3.5 was the average back then.
It's going down.
It's going down. Yes, so there are our categorical descriptives. Pretty good, hey? So now we kind of know what our data set looks like. Okay. So the next thing that we do is we want to do our descriptive statistics for our continuous data, but unlike last time where we did the descriptive statistics for the continuous data and the assumptions separately, we can actually do them together. So do you remember what assumptions are before we jump into that?
Yes, it's
homogeneity of variance is one.
That's one.
yeah, criteria that the data has to meet before it's
Perfect, Dennis. That's exactly what it is. It's factors that need to be met before we can continue with our analysis. If they're not met, then our results could be incorrect or skewed. Perfect. So SPSS allows us to do our continuous descriptives and our assumptions together. So we'll just do that. So we'll go to Descriptive Statistics, Explore. And then we are looking for our continuous. So we want to put age in. Just wait. No, that's okay. We want to put age. We want to put current BMI. I find that one the most interesting. Keeping in mind that BMI is not a great measure of health, but it is the most used measure of health in research because it doesn't require us having to measure somebody. Waist circumference and things like that usually has to be done by the researcher to get a close.
Megan, is BMI a measure of health or a measure of something else?
It's not a measure of anything really. It basically measures like your height versus your weight, or your height divided by your weight. Wait, I can't remember which way.
Yeah.
It basically tells you how heavy you are compared to your height squared. And the reason it's not a very good measure of health is because people who are muscular are heavier compared to their height, but will be healthier. Whereas people who are overweight or obese, they are heavier compared to their height. But then you've also got people who are light boned, who have a small frame. Like I've always been kind of close to that underweight category, but really shouldn't be. So it's not a great measure, but it is the most commonly used measure for health and weight in research for some reason.
Yeah. It's because it's convenient.
It is, just like everything else. But you take the results with a grain of salt.
Yeah, yeah.
Always.
Yeah.
Okay, so we've got BMI. We won't look at the other two BMIs. We've got age of our last child. Then we've got our intuitive eating score, which is our, which one? Which variable is it?
Independent.
Very good. We've got our eating attitudes test, which is our eating disordered variable, which is kind of a covariate in the first research question. And then we've got our depression score. Now we want to look at our descriptive statistics for that one. And then we want to look at histograms, our box plots, because they tell us whether there's any outliers or any variables that might be skewing our data, and then our normality plots. However, with normality, Dennis, do you remember when way back in maybe our first session, we talked about normality and how there's two different ways to measure it? Do you remember what they were?
No.
Histograms, where we look at the bell curve. Yep. The second way, and the most important thing, is the central limit theorem, which suggests that if you have more than 30 participants in each category of your variables, that normality is assumed.
Okay.
Yeah. Now we have 400 and something participants in our data set. So the central limit theorem is probably going to be met despite what our histograms and our normality plots tell us.
Megan, can I interrupt for a second, please?
Yeah.
At the start, you said you'd cleaned your data. Just what were your criteria for data cleaning?
So we just go through each variable and ensure that they match the criteria for each variable. So we just go through and make sure that all of the tick box ones, there's nothing in there that couldn't be ticked. We also look at age. And because our participants were kind of between the ages of, like, say 18 and 50-ish, just making sure that there was no one in there who was like 80 or 90 and be like, well, are you in the postpartum period? I'm not quite sure. Okay. Also for age of child, our inclusion criteria was from 6 months to 5 years, I think. Okay. And so we just made sure that there was no one in there who had a child who was outside of that exclusion range. We actually did have one man complete this, which was interesting.
That's naughty. What about missed responses? Did you cut out any people who missed a lot of questions?
Yeah, so firstly we had to get rid of 300 people who didn't fully complete the survey. So that kind of got rid of most of the missed responses. And then we check the DV and the IV for any missed as well. So if people didn't really finish the scales, then they got removed as well. But we did make the scales a forced response. So they couldn't just miss 1 or 2 in the scale. Okay. Once they started the scale, they had to complete it.
How many questions could they miss and still be counted?
Well, they couldn't miss any because if
they
wouldn't, the survey wouldn't let them proceed.
Okay.
And sometimes that's a really good idea and it gets rid of your missed data. But if someone is trying to skip a question and really doesn't want to answer it, then they'll just skip out of the survey altogether if they can't move forward. We had a lot of women not complete the weight question, which is completely normal. So for them, you'll probably find there's quite a lot of missing data for the BMI calculation, because if they didn't say their weight, then we were unable to calculate BMI. Okay. So there's probably a few missing in that one. Okay,
thank you. I in my thesis, I was criticised in that area because I cut out a lot of people. I was just interested in how and why you did it. Sorry to interrupt there.
No. Feel completely free. The questions are really important. When it comes to removing people, it's best to err on the side of caution and only remove people or remove answers for really good reasons. That's probably why you got pulled up. I've seen other people just remove participants because they didn't answer like 1 or 2 questions. We usually keep participants in as long as they've answered at least 70 to 80% of the data set. So.
Okay, thank you.
No problem. All right, let's have a look at our continuous data and our assumptions. So the first assumption we'll look at is normality. Now, with our research question, does intuitive eating reduce the symptoms of postpartum depression? It's really leaning towards like a linear regression. So we're trying to predict how intuitive eating will affect depression. So the good part about a regression is that most of the assumptions, apart from normality, are built into the regression model itself. So you don't have to like do your assumptions testing really too much before you do your data set. We're really mainly concerned in a regression about the normality of the residuals. So we're more worried about the error than we are about the actual data set. I think we covered that in the other tutorials, but we will go through that when we do our regression. So here's our continuous descriptives. So firstly, we've got age. So who can tell me what the average age is of the women in our data set?
32.
Now, what do we think about that? Do we think that that is a kind of the expected range of women in the postpartum period?
Yeah.
Yep. So that's kind of telling us something about our overall population. So, like I said before, back in the 80s, we used to have more children. We used to have 3.5 in average, and we used to have them a lot younger. 32 is quite old to be in the postpartum period. When I had my son, I was 32, and I was called a geriatric mother in the hospital. And I was told that I had the potential for birth issues or labour issues because of my age. So, so 32 is considered to be a geriatric mother. Anyway, nowadays it's more normal. Back earlier, it would have been mid-20s. Okay, our standard deviation. Who can tell me what the standard deviation is of our age of our mums?
That's
30
months.
Can we see where the standard deviation is? Yeah.
Yeah. That's like 27 to 37.
Yeah, so on average, our data set, our women in our data set range between, say, it's hard to do the maths, hey, 27 and 37, which is interesting considering. What's our, yes, Dennis?
Also
Sorry.
a group of women who have taken time to get higher education. So they've put off having kids for 3 years. It's there.
That's true. That's true. There was quite a lot of people who have been to university.
Yeah.
Yeah. Now, the funny thing about this data set is that it actually didn't suffer the same flaws as my focus group set. So I convenient sampled this and snowballed it through Facebook at the time.
Okay.
And I went back in the days when you can't really do this now, but I went to every mum and bub's kind of Facebook page and promoted it on those pages. Now you can't get through the gatekeepers anymore to do that, but that's why I got like 700 people in like 3 weeks. And yeah, so this one didn't really suffer that problem that we had of having too many overeducated people, but we still ended up with lots of people who had university degrees, which was interesting. But we did get a nice balance of homemakers, women who weren't working at all. So that was quite good. All right. So what was the youngest woman in our data set?
19.
How old was our oldest?
47.
47. Now we had to take a really good look at the participant who was 47.
Hang on a minute.
Yeah. we had to take a really good look at her and the rest of her data to ensure that she was a real case and that wasn't an accident. Because at 47, that's quite old to be having children.
That should be geriatric, not the 32.
I know. 47 is quite old.
It's geriatric. So she was
For
IVF.
childbearing, yes.
She was IVF.
Yeah, let's go have a look at her. We can still do that. See, these are the types of things that happen.
She's a bit of an outlier, isn't she?
She will be, yeah. So if we go to our age and we sort descending, oh, we've got someone who's 48 as well. That's weird. Our maximums, that's very interesting. Let's go have a look at why that's happened.
But you've got quite a few in their 40s. Well, quite a few.
In their 40s, yeah.
Some in their 40s.
Yeah.
Wow.
And it could be their second child, because if people aren't starting until later, the second or third.
Well, the lady who's 47, that's her first. The lady who's 48 has two. I just want to know why the lady who's 48 didn't end up in our data set. That's weird. Very strange. So what else about this lady? So she's 48, she's married. The other one who's 47 is only de facto. One's got a TAFE education, one's only got a high school education. One's a homemaker, one works part-time, understandable. One didn't want to give us their BMI. The other one's BMI is quite low, that's quite good. Normal range. And the first lady's child, youngest child is 208 weeks, which is nearly 4.
Yeah.
And the lady who's 47's child is nearly 3, or pretty much straight on 3. Interesting. But
to be IVF babies.
Potentially, yeah. Cool. Where's our output gone? There it is. All right.
That's really interesting. So why did the 48-year-old not show up? Did you work that out?
No. It might be because I clicked on exclude cases list-wise, which means if everything isn't in their data set, then they won't be included. Maybe I should change that.
Megan, I'm getting worried about myself. I'm getting interested in statistics. Is there something that can be done about that to stop it right now?
Stop coming to my workshops?
Well, it's just useful. It's
really useful.
I can see how useful it is to work stuff out, and
it's fun, hey.
Yeah. Well,
yeah, when I first started doing statistics and research methodologies, they were my lowest grades in undergrad. But I got really sucked into this bit. The descriptive statistic part is really interesting, and it's fun to me, finding out all the different things that are happening and then looking back at the data set and being like, why did that happen?
It's fascinating.
It is.
It's learning about people. You know, I'm a qualitative person, so I learn about people by listening to them. But you're learning about, this is learning about people. It's just the same, it's a different way of doing it.
The only problem with this is, and when I did this data set, was that all these women, these 700 women, answered these questions, but then I couldn't ask them why. And like one woman may have clicked an answer and another woman clicked the same answer but have completely different reasons. And like at the end of this, getting all this data together, I was like, I want to know the reasons why.
So you need open-ended questions in there too.
I need to do a focus group. I just really wanted to do a focus group at the end of this. So maybe I can get an honors student to do that for me one day.
But if you have open-ended questions, if you have a question, you know, what's your age? And your next question wouldn't be this, but your next question could be, how come you're 48 years old and you've just had a baby?
Yeah.
Well, you wouldn't quite word it that way. Bill Boyd would not approve, but
No.
It's a bad example, but you can then immediately ask these people why they said what they said.
Yeah.
It's the beauty of having open-ended questions.
And that becomes really important when we start looking at the intuitive eating questions, like about,
Yeah.
yeah. Now, does anyone know what the cutoffs are for BMI? We did this last time. I think it's, what are they? Let me go look.
I think 24 is the upper one, and
Yeah, I think normal is 18 to 24.
yeah,
And then overweight is up to
30, is it?
30, and then obese is 30 plus. I think that's around about what it is. So that's important to know before we look at our means and standard deviations, because if you don't understand what your variable is out in the normal population, then it's very difficult to interpret it inside your population. So always making sure that you do that before you kind of read your data. So our current BMI is around 28. Now let's talk about that. So that's kind of going into towards the overweight category. Can we think of any reasons why that might be the case?
They're stuck at home with a kid.
Yeah, sometimes it takes quite a long time to lose your baby weight.
Particularly when they're older as well.
Yeah.
To lose the weight.
Yeah, it took me 4 years to get back to my, well, I've never gotten back to my pre-pregnancy weight. That's just not possible and not realistic, and should never be put on a woman to do so. But it took me 4 years to regain shape, tone, everything like that. Mm-hmm. Which was the whole reason why I did this project in the first place. So 28. So we've got a bit of a, on average, a bit of an overweight population, but it's expected because they've just had children.
But Megan, also on average, the population in general is a bit overweight.
Yes, you're absolutely correct.
They're overweight or obese, so.
Yep, you're absolutely correct.
They're actually not too bad.
Yeah.
Could be worse.
So what's our standard deviation looking like for BMI?
Seven.
Yeah, so on average, the population ranges between a BMI of 21 and a BMI of 35, so going up into that obese category.
Yeah.
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 Yeah. Our minimum BMI is around 17, and that's definitely in the underweight category, and our maximum is 54. That's quite concerning.
Megan, could you just inform us of what's the significance of the measurements of skewness and kurtosis here?
Oh, yeah, absolutely. So skew and kurtosis are kind of measures of that normal bell curve. So a skewed data set would look like either all of the participants kind of packed up one end or the other when you have a look at the histograms, which we'll do in a second. And the general rule for skew is that if skew is more than 3 times the standard error of the skew, then it kind of suggests that there is a significant skew in the data set. So the standard error is right next to it. So say for age, 0.069 is definitely not 3 times 0.123. So age looks like it would be quite normal.
Yeah.
BMI, on the other hand, is 0.123. So it's definitely more than 3 times.
Okay.
The skew is definitely more than 3 times its standard error. So it's looking like there would be kind of skew in the BMI, which is what you just said, that most of the population is kind of skewed because there's quite a few down the tail end in that higher category.
Okay.
Yeah, good question.
And kurtosis?
Kurtosis is how high or how flat the data set is.
Okay.
We don't really use kurtosis very much anymore.
Okay.
I've never used it in a data analysis, but it just tells you, yeah.
So how high or how flat the curve is?
Yeah.
Okay, thank you.
No problem. Okay, age of last child, what do we got? So remembering this is all in weeks. What's our average age of our children?
100 weeks.
Yeah, so about
2 years.
about 2. Yep. With a standard deviation of about a year. So ranging between like 1 and 3, which seems quite normal in that postpartum period. Our minimum age was 24 weeks, nice and new, and our maximum age was 245, which is nearly 5, which was our inclusion criteria. So anyone over 5 wasn't really considered to be in that postpartum period. And I was really pushing that because that age range is quite a long postpartum. It's not really. We got pulled up for that in the actual publication. All right, our IV, the intuitive eating score. Now this one's a bit hard because when we looked at our data last time, we just added all of our scales together and came up with a overall score, which is what I've written into the thing, which is not true. The intuitive eating score is done in a different way. And this is why it's very, very important to go back to the literature when you are doing scales and find out how they actually score. So this one, you add up all the 28 questions for each participant, and then you divide it by how many questions there are. So it's actually the average of the scores, and the scores range in between 0 and, let's go have a look. Make sure that I get that right. So where's intuitive eating score? Here it is. Oh, ranges anywhere between 1 and 5. So in our output, our mean is around 3.08. So without really knowing too much about the intuitive eating score, that's quite hard to interpret, isn't it?
It is, yeah.
What does that mean? So what you really need to do is you need to go back to other papers that have used the intuitive eating score and find out what they got. And find out whether ours is very far away or very close to that. Now, in the data for intuitive eating, most papers have an average of about 3.25. So ours is quite close to what other people get for the intuitive eating score, which means that most of their participants, around 60% of their participants, have intuitive eating. So what we're going to do after we do our assumptions testing is we're going to dichotomize the intuitive eating score into 2. We're going to dichotomize them into people who diet and restrict food and people who actually eat intuitively. And the way to do that is by the cutoff score is actually 3. So anyone over 3 eats intuitively, anyone under 3 doesn't. So we're gonna, yep.
Can I just ask a question? Sorry to interrupt.
No.
Intuitive eating again, is that grazing or is it eating what you want? Or?
Yeah, it's exactly like that. So it's eating when you feel hungry, but learning to stop when you're full. That's a really important part. And listening to your body's internal cues about how food makes you feel once you eat it. So say you go eat McDonald's, you know that feeling you get after McDonald's? That's your body saying, I didn't really feel very well after eating that. Whereas you feel differently when you eat something that's fresh. I always feel really good after like roast vegetables.
So it could be an unhealthy way of eating if you just like to eat chips all the time or something.
Well, yeah. But if you ate chips all the time, then you're not eating intuitively because you're not listening to how your body is telling you to eat.
But do you think some people wouldn't have that switched on? So for them, they crave, like they're starving, so they want fat and sugar and everything. So they eat the chips and then they may not notice that they feel unwell afterwards. So they're still eating. It could be argued they're still eating intuitively.
No, because they're not really, they're not in tune to their bodies.
What their body needs.
Yeah.
So, okay.
Another part of intuitive eating is removing weight-focused thinking, which is the most hardest part about intuitive eating. So instead of eating to lose weight or to maintain weight, you're eating for health. And it is the hardest part of intuitive eating. And that's why people think that it's the opposite end of disordered eating, because it's trying to remove that kind of weight-focused thinking. Very difficult.
Okay, thank you.
No problem. All right, so the eating attitudes test, that's the next one. So it measures disordered eating, and it ranges between 0 and 58, I think. And the cutoff score for it is anyone over 20, anyone greater than 20 indicates disordered eating. So what does the mean or the average disordered eating score say about our data set?
Most of them don't have disordered eating.
which is what we would expect, because remember what the definition of disordered eating is: when dieting and food restriction affects your life.
Okay.
It affects your social life. It starts affecting your work life, your family life, your functioning, any form of social functioning. So you wouldn't expect, on average, most of our participants to have disordered eating.
Okay.
And then we've got our depression scale. So the depression scale ranges between 0 and 30, with scores above 9 indicating depression.
Oh dear.
So on average, we have a data set of women who have high levels of depression.
So would that be normal during or more common during the postpartum period?
Most definitely.
Okay.
Yep. There's a lot of added pressures and responsibilities. Women stop thinking about themselves and start focusing on caretaking and keeping the baby alive. There's a lack of sleep, lots of fatigue. It's a very difficult time.
Isolation.
Yep.
Well, social isolation.
Boredom, and a changing of identity if it's your first child as well. A massive change in identity. Your whole world changes.
Wow.
And sometimes you just,
Okay. So would you regard that as a significant finding of this study, or would you regard this as just kind of normal, or?
It's about normal for all the other literature out there.
Okay.
In this population.
Okay.
But we're going to do the same thing with the depression score. We're going to dichotomize that. We're going to put everybody who's under 9 and we're going to classify them as not depressed, and we're going to put everyone greater than 9 and classify them as depressed. We're going to have a look at what the data set looks like, how many we've got in each category, because this just tells us the average. It doesn't tell us how many women are depressed and how many women are not.
Okay.
So by transforming our variable, it'll give us a bit of a better idea of what that variable looks like. So these are our tests of normality. Our Shapiro-Wilks now, I can never say it, Kolmogorov-Smirnov. Reminds me of vodka for some reason.
Megan, if you're a statistician, do you have to have a weird name? If you want to be a famous statistician, you have to have a really weird name. That's my impression. Is that correct?
Maybe, yeah.
Okay.
Now these basically just tell us, and they're not very good indications of normality. So this is why these are very rarely used. But it's basically telling us anything that's significant means there's significant problems with normality. So we just ignore them. Histograms in the central limit theorem are way better. So what does our age histogram look like for normality wise? Very normal. Extremely normal. It's real good to see a proper normal histogram, isn't it?
Yeah.
I forgot to put the bell curve on. That's all right. Now, this is supported by our QQ plots and our PP plots. So if these are very close to the linear line, the dots are very close to the linear line, that means we've got pretty good normality, which we do there.
Really normal.
And then the detrended, if we've got the same amount of dots above and below the line, that's considered to be normal. So age is looking good. Talk to me about BMI.
Could be worse.
Yeah, it's kind of saying the opposite thing to what you said before, Dennis. It's telling us the opposite.
What did I say before? I can't remember.
That most of the population's in the higher BMI categories. Although, if you look at the cutoff for normal, it's about here.
Yeah, I mean, could be worse.
Yeah, there is quite a lot of this.
Yeah.
That's heavy. This is the obese cutoff there. That's a lot of people.
Yeah.
But we've still got quite a lot of people up here in the normal to just slightly overweight category. Now this is a normal BMI chart. Even though the trend's not normal, it's what we would expect to see.
Excuse me, Megan, is overweight over 30 or is obese over 30?
I think obese is over 30.
Okay.
Which is here. All
So
these.
overweight is over about 26 or something, isn't it?
Yeah, I think so.
Okay. Okay.
Now, this is supported by our QQ plots. Look, it's all wavy and showing skew. If it looks like an S, that indicates skew. Our D-trended plot as well. That looks a lot different, doesn't it? Lots more above than below. Although
Yeah.
that's hard to tell because the ones below are all stuck together. Anyway. Tell me about the age of your last child. Looks weird, doesn't it? Why is it doing that?
There are almost two trends.
It is.
I
Why
have
does
no
it look
idea.
like that?
No idea. Tell
Neither
me.
do I. I have no idea either. Strange, hey? Also, looking a little bit not normal. Bit of positive skew in there, which is supported by the other two plots. Right. Now our IV. What do you reckon about that? Intuitive eating.
Fairly normal curve.
I reckon. That looks pretty cool, doesn't it? Love it when that turns out like that. And our QQ plot's kind of showing the same sort of thing. A little bit of coming off the ends of the tails, but pretty good actually. About the same below and above the line. What about eating disordered behaviour? What's that saying?
It's not really a normal curve. It's skewed to the lower end.
What I find interesting about this is that it's very similar to the BMI curve. Isn't it?
Yeah, it is. Yeah.
It would be interesting to overlap these two histograms and see how they look.
So how do you interpret that?
So this is positively skewed. So our cutoff is 20, which is here. So all of these people here would be considered to have disordered eating behaviours, and all these people here do not. So that's pretty good. So it's positively skewed, but that's a good thing because that means most people do not have disordered eating behaviours. So run from here down. So that's good to see, and what you would expect because of the definition of disordered eating. And we can see our skew here. Less below than above the line. And finally, our DV, our depression scale. Now that's weird. That's got some things going on. What's happening there? Here's the cutoff here.
Well, it's not really a normal curve, isn't it?
No, it's
Part of it.
positively skewed again.
Yeah.
Why are there so many people here? Like 70 or so people all in this one category. That's interesting. There's quite a varying degree of depression range as well, from people who are like kind of depressed. So there's like quite a varying range of
So you'd say there's quite a lot in that area just before it's classified as high depression, would you? Like in
yeah. So people who are around about a 7.
Yeah.
But again, with the fact that these are women probably at home on their own with one or more young children.
Yeah. Lack of
expect
social support and things.
You might expect them to be a bit down.
Yeah.
Yeah.
So a little bit skewed. All right. But that's not really a problem because we meet the assumption of normality through our central limit theorem.
I wonder if those people that reported that way just probably are more depressed, but they just don't want to actually report it. So they think, oh, I'll just report here. That's still socially acceptable, yet I'm showing that I'm sad.
That is a really good point about the problem with self-report of depression symptoms across the literature. All depression literature where especially cross-sectional stuff where we get participants to self-report or use scales to report their depression, they might do that. Some overextend while others underextend their symptoms or how they're feeling. And quite commonly it's because of that social acceptance problem where people will either want to show themselves in the best light or they'll malinger and say, oh, I'm so much worse than I am. So that happens.
So, but Megan, I get the feeling that might be a question of self-reporting in general rather than just...
but it's real bad in nutrition and it's real bad in depression. Like it's almost impossible to get a self-reported nutrition like diary or food recall, because people don't remember. Like, do you remember what you ate this time last Friday? What did you have for lunch last Friday?
Who knows?
Who
Who cares? It's not something you try to remember, is it?
Unless you're asked to in a nutrition survey.
Yes.
Sometimes we even ask them what you've eaten over the last month. Tell me what you ate 3 weeks ago on Tuesday.
You could do it generally, but you wouldn't be able to be specific.
It's not specific, no, and that is the problem. And same with depression. Okay. And because the questions are very interpretative as well, like how one person feels compared to another. Someone who feels quite strongly might actually answer a question lower than someone who feels less strongly. Like qualitative is a better way of assessing depression in my opinion, but yes. All right, so we've done our assumptions testing. So the next thing that we need to do is we need to see, before you run a regression and before we can answer our research question, we need to understand whether or not there are actually relationships between our variables. Because if there's not, there's no point in doing a regression, because we can't predict the relationship between two variables if one does not exist. So the next step in our data will be to run a correlation, because a correlation tests the relationships between variables. This will also answer our question between whether intuitive eating and disordered eating are just the same, are two ends of the same spectrum. Because if they have a correlation of higher than, say, 70%, then they're probably measuring the same thing. So this will also answer that question, research question too. So we're going to analyze, we're going to correlate. Where are you? There you are. We're just going to do a bivariate correlation, which just means two variables against each other. And we're going to put depression first because that's our dependent variable and we want to see the outcome in it. So we'll put it first, so it's easy to read the table. Then we'll put our IV. Then we'll put our covariate, intuitive eating, because we want to see how they react to each other. And then we'll put all of our demographics in.
Oh, I don't think we can see your screen, Megan. Oh, yep, that's it.
Sorry about that. All right. So putting all of our demographics in that are interesting. So we've put our DV first, because when the graph comes out, it will be listed first and it will be easy to read. Then we'll put our IV, our covariate, and then all of our demographics. We want a two-tailed test because we don't have a directional research question, and it's pretty smart to only ever do two-tailed tests. We want a Pearson's correlation because we've got pretty normal data. We don't really need to worry about that. And we don't need our means and standard deviations because we just saw them. So we won't ask for them. We'll just ask for a basic correlation. Now, do we remember how to read this?
Yeah, vaguely.
All right, we'll go through it again. So depression is our first line, and you pretty much only really need to read that first line to see what the relationship between depression and all of our other variables are. So the first column is depression. So it has a correlation of 1, which means correlations range anywhere between -1 and 1. A correlation of 1 means there's a perfect relationship between the two variables. That makes sense because depression would have a perfect relationship with itself. So it's got a 1. Anything between 0 and 1 or 0 and -1 tells us the strength of the relationship between two variables. So we'll have a look at intuitive eating and what it tells us. So the correlation between intuitive eating and depression is negative. So what that means is that as intuitive eating goes up, depression goes down.
Wow.
Yeah, so that's good. And the strength of our relationship, so 0.355 is about a moderate relationship. So anything less than kind of 2 is very weak. 3 to 5 is a moderate relationship, and anything greater than 5 is considered a strong relationship. So we've kind of got a moderate relationship between intuitive eating and depression, and that's highly significant at the less than 0.001 level. Now, do you want to tell me about the eating disorder variable? So as eating disorder goes up, what happens to depression?
Goes up.
Yep, it does. And it's got a moderate relationship as well. Now, as age increases, what does depression do?
Goes down.
It decreases. Now, this is very commonly seen in the literature. As we get older, our depression symptoms decrease. So this is what we would expect, but that's quite a low relationship. So we wouldn't use age in the regression because of the weak relationship. So marital status. Now we have to understand how marital status was measured to understand the, so let's go have a look at that. So married, de facto, okay. So as marriage status goes from married to single, that's how we are interpreting this. What does depression do?
Goes down.
No.
Oh. Yeah, you're right. Yeah.
Goes up.
Very slightly, yeah.
So it seems like the direction that people, as you go from married to single, depression goes up. However, weak relationship.
Yeah.
What about income? As income goes up, what does depression do?
Goes down.
It's down.
Yep.
Moderate.
Yep.
Yeah.
Makes sense.
Yeah.
As education level goes up, what does depression do?
Goes down.
That's interesting too, isn't it?
That's really interesting. Is that in people in general, Megan?
Yep.
Okay.
This is what we would expect to see. Weak relationships though, very weak. They're significant but weak.
Yeah.
Yet there's such high levels of depression in those who are studying. So that's interesting.
What about employment? As employment goes from, let's go have a look, make sure I get it right. Okay, so as employment goes from not employed to employed, what does depression do?
Goes down slightly.
Goes down, pretty weak relationship. Still significant though.
Yeah.
As the number of children goes up, what does depression do?
Not much.
It doesn't do anything because it's not significant.
Yeah.
Yep, so we've got a 0.874 significance level for that one. Okay, here's an interesting one. As BMI goes up, what does depression do?
Goes up.
Makes sense?
Yeah. Not happy about themselves.
Yeah. And what happens with the age of the child? As the age of the child goes up, what does depression do?
Goes up very, very slightly.
But it's not significant, so it's no relationship between the age of your last child and your depression levels.
So would you just not say anything about it if you were reporting that? You just wouldn't comment on it? if
Yeah,
it's not
so
significant.
what the correlation matrix does, it tells us what to include in the regression and what not to include. So anything that's non-significant or has a weak relationship, I wouldn't include in the...
Okay.
So pretty much all of our demographics are weak. So I would not include them. To be honest, I'd include BMI just because it's interesting. But the rest I wouldn't include. So we just use our variables and BMI. But if these were strong relationships and significant relationships, then they would become part of the regression to see if they're predicting part of the relationship in depression. It doesn't really look like they are here. Okay, so the next question now, research question number 2. Is intuitive eating and disordered eating the same concept, but just 2 different ends of the same concept? Or are they completely different variables measuring different things? So the correlations matrix tells us that. So we go to the next row, intuitive eating score. We go over to the eating attitude score. What does that tell us? As disordered eating goes up, what does intuitive eating do?
It goes down.
It's down.
Or the other way around. As intuitive eating goes up, disordered eating goes down. What is the relationship? What is the strength of that relationship?
Substantial.
It's strong.
It's strong.
But the way that we determine whether or not 2 variables are measuring the same thing is if they're kind of over 80, so 0.8, they are considered to be collinear, so have multicollinearity. These are measuring something similar, and there's a strong relationship between the 2, but they are not measuring the same thing because they're not over 0.8.
So they're not on a continuum.
They're not, no, they're measuring different things.
Okay.
Cool, huh?
Yeah, okay.
And then the next step is to go through the rest of the data and just make sure that the other variables are not collinear, which we kind of have already done because we're not really looking at BMI. We can look at BMI and 0.47 and 0.13. So BMI is also not collinear with intuitive eating and eating disordered behaviors. So the correlation matrix has basically told us what to put into our model, into our regression model, and we can go and do the next step. Oh, I've lost the data set. There it is. Okay. So the final thing is to do a regression. Now, do you want to dichotomize the intuitive eating variable and the depression variable first, or do you want me to run the linear regression first? It doesn't really matter which way we do those.
I have no idea.
Don't mind. You decide, Megan.
All right, let's run the linear regression first, and then we'll have a look at the trends in the data. All right, so we're going to analyze. We're going to do a regression, and we're going to do a linear regression, which just means that we've seen that we can put our data on a straight line. Yeah. Actually, before we do that, we might look at a scatter plot of the data just for fun. So we might do a scatter plot of the DV and the IV just to see what the relationship looks like that way as well. So we put intuitive eating on the y-axis. I hope I got these around the right way. I can never remember which way they go. Depression on the x-axis, intuitive eating on the y-axis. Let's see what happens. That looks like no relationship to me. No, that's not true. It's got like a slight, like...
Should it be the other way around, Megan?
No, because as intuitive eating goes up, depression goes down. So it's definitely got a negative skew. Oh, you mean the variables?
Yeah, so hang on. So what goes on the X, the IV?
Does it? I've got them around the wrong
I'm pretty
way.
sure, doesn't it? Oh, don't quote me on it.
Oh, no. I think
but
you might be right.
I'm not, yeah, I think so.
IV on the X, you reckon?
I think so, but don't quote me on it.
CV on the Y. Let's see what it looks like when we do that. Yeah, it's still negative. That's actually much better. If we put the linear line through it, yeah. Interesting, hey? So it definitely has a negative trend. So as intuitive eating goes up, depression goes down, which is great. But you can see that very weak relationship because the dots are like kind of scattered everywhere. They're not like really close to that line. And that's reflected in that correlation of 2 point something. You can see the R squared up here. And the R squared basically tells you how much variance intuitive eating has in depression. So there's about 13%. So basically intuitive eating takes up about 13% of depression, whereas other things take up the rest.
Megan, what's your interpretation of this result in terms of why? Why does more intuitive eating lead to less depression? What's the...
Oh, my paper actually explains that. It's because intuitive eating leads to higher levels of body image satisfaction because you're not body focused. Whereas people who diet and food restrict are very conscious of their body, and small fluctuations in body weight and size can lead to depression. Okay,
thank you.
Yeah, so the actual honours project that I did, body image satisfaction was actually the dependent variable, and depression was just a covariate. So intuitive eating and body image satisfaction were the main variables. So cool. All right, let's do this regression. And the funny thing is, in my data set, intuitive eating took up 65% of the variance in body image satisfaction. That's massive. So that's basically saying that 65% of the reason that people have bad or negative body image is because of the way that their food patterns or their decisions to eat or diet. So if we can stop people from dieting and restricting food and being weight focused thinking, depression levels will go down. I mean, body image satisfaction levels will go up dramatically, which seems like common sense to me now because I've been working on that for years. All right, let's do our regression. Linear regression, what's our dependent variable?
I'm sorry, I'm still thinking of what you just said.
That's okay.
Yeah,
okay.
I'm just behind the 8 ball too. Which one are we, forgetting which one we're doing.
Yeah.
Depression.
Second one, depression.
Yeah.
What's our independent variable?
Body image?
Intuitive eating.
Intuitive eating.
Yeah.
Oops.
Yep. That's okay. So we'll put it into the model first. The second model, we will add disordered eating behaviours, and the third model will add BMI. Then we want to look at confidence intervals. We've kind of done a covariance matrix. We want to see the change in the R squared between the models. Descriptives, collinearity diagnostics. So that is our assumptions testing. So is Durbin-Watson. And our case-wise diagnostics tell us if there's any outliers in the residuals. We want to look at a plot of the predicted values versus our residuals, and that will tell us whether or not our residuals are normal or not. So remembering in regression, it's very, very important to have normal residuals rather than normality of the data set. All right, let's go. Let's see what this tells us. Okay, so our means and standard deviations are the same as what we found in our assumptions testing. We've got a mean or average depression rate of about 11. Intuitive eating score is about 3.09, and our eating attitudes, disordered eating, is under 20, which is good. And BMI is around 28, so we've got a bit of an overweight population. There's our correlations again. So we don't really need too much of that. Okay, here's our models. So model 1 was intuitive eating and depression. Model 2 was intuitive eating and disordered eating. And model 3 was intuitive eating, disordered eating, and BMI. Now, in our first model, our R squared is 0.121, which tells us that intuitive eating by itself has about a 12% variance in depression. So it takes up about 12%. Other things take up the rest. And that is the significant. The second model, when we include eating disordered behavior, it goes up to 0.179, so another 5.8. So the R squared change is 0.058, so it adds another 5 to 6% of the variance in depression. So not too much. And then adding BMI adds another, so it's 187, so it adds another 0.8% to depression. Now the box below it, ANOVA, tells us whether or not our models are significant. So all three models are significant. That means that from here we would just look at the last model, which includes intuitive eating, disordered eating, and BMI. The coefficients box tells us in the model which variables are significant and how much they take up. So our standardized beta for intuitive eating here in our third model, which is what we're looking at because all three models are significant, tells us that as depression increases, as intuitive eating increases by 1 standard deviation, depression score decreases by 0.123. As disordered eating increases by 1 standard deviation, depression increases by 0.311. And as BMI increases by 1 standard deviation, depression increases by 0.103. And all those statistics, those T statistics, are significant. However, intuitive eating and BMI are, no, they're not. They're not significant. 0.05. Yeah, they are. So you get confused to where the point is. So they're just under that significance level at 0.049 or 0.048, which means they're significant. However, if they were 0.051, they would not be. And herein lies the problem with dichotomizing significance levels. What's the difference between a significance level of 0.049 and a significance level of 0.051? Not much. And that's why we usually use confidence intervals to tell us the strength of a relationship or whether a relationship is significant or not. And a lot of literature is moving away from reporting p-values to reporting confidence intervals for that reason. Yep. Now over here on the end, we've got our collinearity statistics. We've already looked at our correlation matrix and seen there's not really any collinearity between the variables. So these should all be quite good. So tolerance should be greater than 0.02, which they are, and VIF should be less than 10, which they are. So that supports our look at the correlation of the covariance matrix. Oh, we don't need too much of these. Oh, the collinearity diagnostics tell us whether or not there's any outliers that are to be concerned about. If there's any over 3, there's cause for concern, which we can see here in the final model. There is one greater than 3. So that would be worth going and checking out and decide and making a decision on what to do with that person. It means that they're an outlier on both the intuitive eating variable and the depression variable. And here are our charts for our residuals. So whether or not our residuals are normal. What does that look like to you?
Fairly normal.
I would say that's a bit skewed.
Well, it is, you're right.
So
the black is a normal curve.
yeah, it is.
Okay.
So it's a little skewed. And you'd probably want to transform your DV. Transformations are a concept for another day. That's what's happened to your data. Hey, Dennis, your data was like completely not normal and you had to like do transformations.
Yeah.
Yes. Okay. So that's our regression. Basically, it's telling us overall that there's a relationship between intuitive eating and depression. It's kind of small, though. The unstandardized beta was like quite small and just significant. So there's basically what that's saying is that there's probably other things out there that are causing the depression more than whether or not a woman's dieting or eating intuitively. Okay, now we've got to half an hour, so we have time to dichotomize our variables and have a look at what they look like when we do that. So we might do that. We're going to transform the intuitive eating and the depression variables, and we're going to change them from a continuous variable into a dichotomized variable, because right now we can see where people lie on the continuum for intuitive eating and depression, but we can't really see how many are depressed and how many are not depressed, or how many eat intuitively and how many diet or restrict food. And that would be a really interesting thing to be able to put into our participant characteristics section of our results. So to do that, we just go transform, recode into different variables. We find our variable for intuitive eating. We rename it intuitive eating scale dichotomous. Is that how you spell that? Hopefully. Intuitive eating dichotomized. We go into old new values and we go arrange. So anything from 0 to 2.99 is considered to be people who are dieting or restricting food, and we give them a 1. Anyone between 3 and 5 is considered to be intuitive eater. They get a 2. Continue. Okay. Then right at the bottom of our data set will be our new variable. Make sure that everything's right. We don't need more. Maybe we do. No, it's dichotomized. We don't. And then we need to go into the values, and we need to tell the SPSS that we want to nominate number 1 as those who are non-intuitive, maybe. And we want to nominate number 2 as our intuitive eaters. That's not spelled right. That's okay. So that's our new variable. Let's go have a look at it. So we want to go to our data view and just take a look at our new variable all the way at the end. And now everyone in that data, in that variable should be either an intuitive eater or a non-intuitive eater. Looking good. Then we want to go analyze, descriptive statistics, frequencies, throw our new variable into the variable box and get a bar chart of percentages. And this will tell us how many we have in each category. There we go. So now instead of seeing this intuitive eating scale on a continuum, which is really hard to interpret, we now can see how many women we have who are intuitive eaters and how many are not intuitive. So what does this tell us? What percentage of women are intuitive eaters in our data set?
56.
Yeah.
7.
And how many are dieting or restricting food?
43.
That's quite concerning. But it's completely understandable in this cohort of women, because what happens is women are exposed to social media, exposed to television and celebrities who have children and immediately lose their pre-pregnancy weight. Immediately. It's all over the media, everywhere. And so women feel like they're expected by society to go back to their pre-pregnancy weight as quickly as possible, and they often turn to food restriction and dieting. So it's pretty normal that we've got quite a large percentage of women who are dieting and restricting food. Yeah.
That's good.
Yeah.
Very good.
So let's go have a look at the depression variable, because it's on a continuum. It's a bit hard to understand. Let's go and transform it into, put depression in, we'll rename it there's just like heaps of different ways that you can look at variables when you get them, which I really like, and you can do different analyses on them and see if they support each other. Old and new values for this one. So what was the depression scale? It was 0 to 30. Anyone greater than 9. Okay. So range from 0 to 8.99 with a value of 1 was considered to be not depressed. Anyone from 9 upwards was a 2 and was considered to be depressed. Remembering that this is a diagnostic tool, so it actually is measuring depression rather than depressive symptoms. So now that we have created our variable, where is it? All the way down the bottom. We need to tell SPSS what the labels mean. So 1 meant depressed and 2 meant depressed. And then we want to go analyze, descriptive statistics, frequencies, reset, put our new variable in there, depression. Get a bar chart of percentages. And let's have a look at what we found. That's interesting, isn't it?
Yeah.
So half of our data set was depressed. That's quite large. That's quite a high level as well, for probably the same reasons that we talked about.
Yeah.
But as you can see, transforming the data like this helps you to interpret it a lot easier than just looking at the continuum or looking at means and averages and standard deviations and things like that. One thing that you can do is you can run a logistic regression using the depression DV as the dichotomous value if you want to. You lose a little bit of information doing that though. So I would only suggest doing that if your residuals are not normal. Kind of like what happened to us in the linear regression. It's one way of reducing that problem with skew of residuals. That's it, I think. Are there any questions about what we've looked at?
Oh, that was good. Very helpful, as the others were.
I have a lot of questions, Megan, but I don't know enough to know how to pose them. No, I'm just joking. I agree. It's been very, very useful. And as you know, I've done my data, but I'm not a statistician. This has been very, very useful for me to go through this at this pace in this way. It's been terrific.
It has.
I think like going through things and repeating things is really important as well. And not just seeing something once. It's like going back over things that we've already looked at is really important to embed that learning.
Definitely. It makes it less scary too when you kind of do it a few times and you think, oh, I'm actually not going to do anything wrong. That's the thing that I have the most. I'm worried if I press the wrong thing, I'll have to start all again. But yeah,
you're doing your
not
thesis.
Afraid of the data, I think, is the most important thing. Just trying new things and
are you doing your thesis this
year? I
thought so. How exciting!
Plan anyway. Yeah, I don't know. Supervisors will probably come out soon. I haven't heard of any. I haven't got an email or anything about that yet. But
yeah. And what are you thinking of doing? Are you thinking of doing a survey-based type thing, or? I'd
like not to, or maybe part of, if I can. But yeah, I'm still a bit undecided about what I want to do.
That's okay.
Anyway, I've got a couple of ideas. But
yeah, supervisors will give you guidance as well, which is really good.
Yeah, or you may have to do what they want to do too. So
potentially.
Yeah, I wasn't getting too carried away with that yet. Just wait and see.
How exciting. Writing the honours thesis is so much fun.
Megan, sorry, I just want to say, Megan, the other thing I found useful here is that we're not going through this in bits and pieces. For example, supervisor said to me, well, you should do a factor analysis. So I said, well, what's that? And they said, go away and find out. What we've done here is taken a real set of data, not too complicated, and just started at step A and then moved to step B and then moved to step 3. So it's been a flow rather than all of these separate bits that don't mean anything.
Yeah.
Apparently aren't connected, but are. So you're an actual teacher, so I've really appreciated that.
Factor analysis actually happens before this. So factor analysis is basically, see these questions here on the intuitive eating scale. Someone would have created these and thought, well, first they would have done a qualitative study, right? And asked all women about intuitive eating. And then they would have created these questions from that qualitative study.
Yes.
That's the first step.
Yep.
Then they would have taken all these questions and run a factor analysis on them and then grouped them. The factor analysis would have grouped them into themes.
Yes.
And the intuitive eating scale is actually grouped into 4 different themes. I can't remember what they are, but they are. Okay. So you can actually break this scale into 4 as well, which is really cool. And the factor analysis also validates a scale and says these questions are measuring what we intended to measure. And so factor analysis is kind of the very first step of this. And one of the main things with the factor analysis is you need to ensure that your factor analysis comes out significant before you unleash your scale on the world if you are creating one for yourself.
Yes.
Yeah. And then you do the rest of this once your scales are all validated. And that's why a lot of researchers use pre-validated scales, because it removes that whole first step.
Yeah.
But in a PhD, it shows a lot of skill to be able to do that.
To be able to do what?
The factor analysis.
Okay. Well, I had a lot of help.
But you probably needed it. Just like I needed a lot of help doing my longitudinal analysis. It's not something that I'd ever experienced before,
Yeah.
and never had done. So I don't think you should feel silly not knowing a statistical analysis, because until you've been taught how to do something, how is it? It's just not knowledge.
Exactly. And I know if you do a PhD in America, you have to do certain subjects, lectures and examinations in them, one of which would be statistics. In the Australian or the British system, you just start off and work it out as you go along. So it might be a little more difficult.
That's why we're really lucky in psychology, because we do like 4 or 5 advanced statistics courses during our undergraduate degree.
Yeah.
Yeah, and so that kind of sets you up for honours, PhD. Whereas I know a lot of the other schools don't do that.
Yes. Yeah.
Yeah.
Megan, another thing that struck me here is the importance of the quality of the sample population you get, because I'm finding this is very interesting, but I can realize now how it's limited to a certain group of participants who were recruited in a certain way. And
Yeah.
I'm making no comment if that's good or bad, it just is. But it's really come home to me very strongly about how getting the survey, the population you need is so important.
Really having your inclusion exclusion criteria really firm in your mind before you do that. So one of the things that we got slammed for in my honours thesis when we published was that we made a decision right at the beginning to exclude women who were breastfeeding still, because we felt that that would influence pretty much all of the variables. So we excluded women who were breastfeeding, and we got slammed by that in the publication stage. So, which is interesting. And every time you get a little piece of advice or you do something wrong like I did, like lost those 300 participants, you learn and you mold. And then the next time you do something, you do it a little better, and you don't make the same kind of errors that you made in the previous ones.
Yeah. Yeah.
And so when you're doing honours thesis or you're doing a PhD, you're expected to make mistakes. There's no way you can do a perfect honours or a perfect PhD. This is the first time you're engaging with statistics. It's the first time you're creating a survey. It's the first time you're doing all of these things, and you're not expected to know. That's why supervisors are there to guide you.
Yeah.
But they can also miss things.
Yeah. Yeah.
So, and we're all human.
I think people think in terms of research of some very structured, organized process, but really, in a way, it's controlled chaos, isn't it? Because you never know what's going to happen.
That's exactly right.
Yeah. Don't tell anyone, will you?
And that's why imposter syndrome is so frequent in these higher education levels, is because most of the time we have no idea what's going on or what we're doing, and we're just winging it. And so we're like, someone's going to walk in here in a second and be like, right, Megan, get out.
Yeah.
You shouldn't be here. What are you doing on that statistical program? You have no idea what you're on about.
Not true. We need to keep you. You need to be around next year. I think you need to do this every week.
Called imposter syndrome, Megan.
Yeah.
Yeah.
But that's also completely normal.
Yeah, I've found this immensely valuable. I'm really grateful to you.
Oh, that's amazing. Thank you so much.
Yeah. Megan, where are you? You're doing your PhD now, is that correct?
I have 6 months to go.
Okay.
So I'm in that final write-up stage, which I actually think is the most difficult part of the thesis, to be honest.
Well, I hope you don't nearly have a nervous breakdown as I did when I was there. That was the hardest part. It was horrible for me.
Yeah, I've had mine already. So I'm done. I'm done. I've had it and I'm over it. So hopefully I don't have to.
Good for you.
You're good now. The easy part now. You'll be fine.
Yeah.
You're also tutoring and or teaching?
Yeah, I am. Yeah.
What are you doing there?
I
If I-
teach psychology, I teach sociology, and I teach stats. Yeah,
Okay.
I love teaching stats, as you can tell.
Do you
Yeah,
teach honours stats? I've got to do stats this.
Not yet. Not yet, but
No.
I do tutoring for honours students if they need help with their
Okay.
stats. So if you need that, just email me
Thank
at any
you.
stage.
Sounds awesome.
Always keeping in mind that your supervisor's guidance is always trumps anything that any tutor tells you.
Okay.
Masters.
Hopefully I get offered a position as a psych lecturer soon.
Well, you're a natural teacher, so I think you probably will.
You will.
Hope so. We'll see what happens when my PhD finishes.
Yeah, yeah. It's interesting that you're teaching and on the basis of your masters, because universities don't do that, I understand.
I don't even have a master's, Dennis.
Oh,
I've
well,
only got an honours.
that's even more interesting in the case, because I know that I think it was CQU got rid of a lecturer because he didn't have a PhD there.
Yeah, SCU is like that as well. So SCU expects you to either have a PhD or be in the process of completion.
Okay.
So as long as you are on your way, then
Yes.
SCU considers you okay
Okay,
to teach. Yeah.
great, great. Mm.
Excellent.
Well, that's it from me.
Thank
Okay.
you, Megan.
Yes, thank you.
Terrific. Really
No problem. And the Southern Cross Postgraduate Association will have this, all these recorded if you ever want to go back and revisit them. If you end up doing something similar to this and wanting to go through them step by step, you can pause and rewind and things like that. So it's really handy to go through.
Very valuable.
Yeah, for sure.
Excellent. Well, thank you everybody for coming.
Thank you, Megan.
Thanks, Megan.
No
See you
problem.
around.
See you
ya.
later.
Bye.